2.3, light and other waves. Light plays a critical role in many electronic and electromechanical systems. There are systems that distinguish between the presence or absence of light, measure or control brightness, and respond to or manipulate the color of light. Optoelectronics is the term that refers to the use of optical devices in electronic systems. Candle power is the measure of light intensity. Sound waves. Acoustical sound waves are measured in decibels, and decibel is the unit of measure that we use in measuring sound. An intensity of a sound wave is a measure of how loud it is, and your text has a table of sounds and the related dB levels. We will briefly address decibels in Chapter 10, and decibels, though we're looking at it in relationship to sound here, decibels can also be used in measuring RF energy. Wavelength and frequency. The color of visible light and the tone of a sound wave is determined by its frequency. And in the next couple of slides we're going to be looking at terms related to wavelength and frequency. All waves exhibit common properties. A wave consists of repetitive peaks and valleys, and so here we have a wave, and you notice here we have the peaks, and here we have the valleys. Wave velocity, notice here, or speed, is determined by the medium and the characteristics of the wave. Wave velocity. Now, we're going to look at acoustical sound and light. Now, acoustical sound travels at a velocity of 1,128 feet per second. We refer to that as the speed of sound. Light waves travel at the frequency of 186,411 miles per second, or 300 million meters per second. So there's quite a differentiation between the speed of sound and the speed of light. Wavelength and frequency. Wavelength is the physical distance between corresponding points on two consecutive waves. And notice when we talk about wavelength, we're talking about a distance. We're not talking about time, we're talking distance. Wavelength is determined by dividing velocity by frequency. And so velocity, we would have to look at the two things we just looked at. Is it the velocity of sound? Is it the velocity of light? Here we have a question. This comes from your textbook. What is the wavelength of a 500 hertz sound wave, and how far will it travel in 1 second? So we know that the velocity of sound is 1,128 feet per second, and we know that we're looking at a 500 hertz signal. So that means that there are 500 cycles in 1 second. So we're saying, what is the length of one cycle? And the simple division here tells us, well, one cycle is 2.26 feet in length, and that is its wavelength. Okay, the period of a wave is the time. Now notice when we looked at wavelength, we were talking about the length. Now we're talking about the time of a wave. The reciprocal of a wave's frequency is its period. For example, the electrical current we use out of the wall socket is 115 volts at a frequency of 60 hertz. Since the cycle repeats 60 times a second, the time of one cycle is 1/60th of a second, or 0.17. So here we have this wave repeating 60 times a second, so 60 cycles. And when we say that, that means that it changes 60 times a second. And so when we look at the period, we're saying, well, how long is the time of one cycle. So we simply go 1 divided by 60, and we get the time of about 0.017 is the time of one cycle. And something I might mention here is that when we evaluate the one cycle, we look at, and you can start at any point, but you have to start at one point and go to that same point in the next wave. So we could say one cycle is the time from here to the time right here. Likewise, we could have said, well, the time of a wavelength. I mean, it's the same thing. From this point to this point is one period or one cycle. We could have said from here to here. We're looking at one, and here we saw one complete cycle is from here to here. And just one way of recognizing that is to just go from one point on the sine wave till you get to the same point on the next wave, and that will be one cycle. Okay, this was a brief length lesson. We simply looked at wavelength and frequency. We looked at the period of a wave. We also looked at the wavelength, and we determined the difference between the two. Wavelength has to do with distance, and period has to do with time. We looked at the speed of sound. We looked at the speed of light.